Earth is the planet which we call home, along with all living creatures. Responsible for harboring all this life, though, is the closest star to Earth, the Sun. The Sun has been around for 4.6 billion years, but it won't be around forever. This is a story about the death of the Sun. After about 10 billion years on the main sequence, fusion exhausts the hydrogen in the center of the Sun. Therefore, its core internal pressure diminishes because temperatures are not yet sufficiently high to fuse helium into heavier elements. Explained by hydrostatic equilibrium, gravity pulls the core in, heating it up again. Hydrogen begins to burn more vigorously in the now hotter shell around the core. The new energy causes the outer layers of the Sun to swell by a factor of 10 or more. When the Sun reaches this stage, its diameter will be about 60 times its current. Only about 3000 Kelvin, the solar surface will be relatively cool for a star, so it will appear reddish. Such a star is called a red giant. The Sun will be in this stage for about 1 billion years, 10% of its entire life on the main sequence. The contracting core eventually becomes so hot that helium will start fusing into carbon and oxygen nuclei. But this stage will only last a brief time, perhaps 100 million years. During this time, the Sun becomes slightly cooler and fainter. We end up with a star whose core is carbon and oxygen and is surrounded by shells of helium and hydrogen that are undergoing fusion. Not being hot enough to fuse carbon nuclei, the core once again contracts and heats up, generating energy and causing the surrounding shells of helium and hydrogen to fuse even faster than before. This input of energy makes the outer layers expand again, and the star becomes an even larger red giant. As the star grows still larger during the second red giant phase, the loosely bound outer layers can continue to drift outward until they leave the star. The remaining part of the Sun will be its exposed hot core, which will reach temperatures of 100,000 Kelvin, and so will appear bluish. It is known as the central star of a planetary nebula. At this point, the Sun will be on its way to becoming a white dwarf. Summarizing the Sun's evolution off the main sequence begins with it becoming a red giant, growing much more luminous and a bit cooler as its helium core contracts while surrounded by a hydrogen-burning shell. This stage will take about 1 billion years. When the core becomes sufficiently hot to ignite helium, producing carbon and oxygen nuclei, the Sun will briefly, for only about 100 million years, become a bit less luminous and hotter. It will subsequently become an even larger red giant, growing even more luminous and slightly cooler as the carbon-oxygen core contracts while surrounded by helium-burning and oxygen-burning shells. The Sun will then lose its outer envelope of gases through winds and gentle ejections, producing planetary nebulae and revealing a hotter surface. The luminosity, however, will stay roughly the same as the burning shells of hydrogen and helium generate the energy. Thus, the Sun will quickly move to the left in the temperature-luminosity diagram. When the contracting Sun reaches roughly the size of the Earth, pressure from electron degeneracy will dominate completely, thwarting further contraction. However, the Sun will continue to cool, making its way to becoming a white dwarf.